Hello everyone, welcome again to Standard 10th Geometry class. Today we are starting our new chapter, that is chapter number 7, Coordinate Geometry. This is part of your unit 3 and it has weightage of 6 marks in board exam. So let us begin with this coordinate geometry. Children, in 9th standard, you have already studied the basic concepts of coordinate geometry. You know how to plot a point on XY plane. So can you tell me what is the other name of XY plane? Yes, Cartesian plane, where we draw two mutually perpendicular axes. The horizontal axis is called x-axis and the vertical axis is called y-axis. So let us quickly revise all the important points which you have already studied. Point number 1. In class 9, you have studied how to locate the position of a point on a plane. We draw a pair of mutually perpendicular axes. Horizontal axis is called x-axis and the vertical is called y-axis. And the distance of a point from y-axis is its x-coordinate. And what is the other name of x-coordinate? Abscissa, right? And the distance of a point from y-axis is its x-axis is its y coordinate and the other name of y coordinate is ordinate, right? So children, you remember this second name of x coordinate and y coordinate because they may ask you in the form of abscissa and ordinate, okay? And the point at which two axes meet is called origin. So this you know. And the next point, the coordinates of a point on the x-axis are of the form x comma 0. What does it mean? That means all the points which lie on x-axis, they have their y coordinate 0. And a point on the y-axis are of the form 0 comma y. That means all the points which lie on vertical y-axis, they have their x coordinate 0. That is why in the form 0 comma y. And the coordinates of the origin is fixed, always 0 comma 0. This coordinate geometry, it has numerous application in our daily life. So what are those branches where this coordinate geometry is useful? So coordinate geometry is widely applied in physics, engineering, okay, in navigation, like in marine engineering, to give the direction to the ships. This coordinate geometry is used in seismology. What is the meaning of seismology? Study of earthquake. So there also that pattern is drawn on Cartesian plane, okay, and that peak denotes the intensity of the earthquake. So that seismograph is drawn on Cartesian plane. Similarly, you might have seen ECG, that electronic cardiograph, that is also drawn on Cartesian plane. So just by looking at the pattern, doctor, they diagnose whether the heart is working properly or not. So in this way, this coordinate geometry is widely used. Now we see some advanced formula how we can find the distance between any two points which are on this Cartesian plane. Up till now you have just plotted the points. Now this year in 10th standard we will study how we can calculate the distance between any two points which lie on this Cartesian plane. Okay. So if the points lie on the axis, the distance between them can be found easily by using the formula larger coordinate minus the smaller coordinate. So this is easy case. Okay, so just to explain, first of all, I have drawn this horizontal line. Suppose this is x-axis and our 2 points A and B, suppose they lie on x-axis. A has coordinate 2 and B has coordinate 7. So the distance AB is calculated by using this simple formula. Larger coordinate minus the smaller coordinate. This B, point B being right hand side to A, its coordinate is larger, that is 7 minus 2, 5 units. That means if the points lie on the axis, very easily we can find the distance between them. What if the points, they do not lie on the axis or anywhere on the plane? So for that, let us derive one formula which is called as distance formula. So that is used to find the distance between any two points on the Cartesian plane. So let us do that. So for that, you need to take any 2 points on the Cartesian plane. So let us now find the distance between any 2 points, say P x1 y1 and Q x2 y2. So let me show on Cartesian plane. Here I have taken point P. This is point Q. Point P has coordinates x1, y1. Q has coordinates x2, y2. From this point P, I have drawn perpendicular line along x-axis and also perpendicular along y-axis. Similarly, from this point Q, drawn perpendicular along x-axis and also perpendicular along y-axis, and you just extend this line, so you will get this triangle PTQ, which is a right angle triangle. And this PT distance, now you see x coordinate of point P is x1, so this O to R distance is x1. Now x coordinate of Q is x2, so O to S distance is x2. So that is why this RS distance is equal to x2 minus x1. Similarly, this TS distance is y1 and this QS distance is y2, being y coordinates y1 and y2. So you subtract, so QT distance is equal to y2 minus y1, right? So now we have QT length, we have SQ length or PT length. So let us apply Pythagoras theorem in this right angle triangle PQT. So PQ square is equal to PT square plus QT square, right? But PT is how much? PT is nothing but x2 minus x1 the whole square plus QT is y2 minus y1 the whole square. Now this is PQ square, but we want value PQ. So on taking square root on both the sides. So take square root. So PQ is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. And this is called the distance formula. Since the distance is never negative, we take only positive square root. You know, if the answer is square root of 25, so it has two values, plus 5, minus 5. But here we are dealing with the distances and distance is never negative. So we will take only positive value, right? So remember, this is our distance formula. Now let us see the examples based on this distance formula. Find the distance between following pair of points. The coordinates of the points are given 2, 3 and 4, 1. So let us give some name or some alphabet to these coordinates. Let A say 2, 3 denoted by x1, y1 and B 4, 1 denoted by x2, y2. Right. Now use distance formula. So formula is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So your x1 y1 is 2, 3 and x2 y2 is 4, 1. So accordingly you substitute the values, simplify it, you will get answer as square root of 8. You further simplify, you will get it as 2 root 2 units. Right. So this is very straightforward sum. Now next, distance of a point from origin. Okay, so previous was the case when the coordinates of both the points given to you. Here one point is always fixed, and what is that fixed point? Origin. And you know the coordinates of origin are always 0 comma 0. So one point is fixed and other point is say P, whose coordinates we have taken as x comma y. So let us derive formula, and after that we will use directly this formula for finding the distance of any point from the origin. So let the point P be x comma y, and being origin O, coordinates are 0 0. Apply distance formula. So x minus 0 the whole square plus y minus 0 the whole square. So finally you will get square root of x square plus y square. So this is the formula for distance of any point from the origin. Okay, so let us solve one example based on the above formula. Find the distance of the point P 4 comma minus 3 from origin. So P has coordinate 4 comma minus 3, consider it as x and y, and O has coordinate 0 0. So now you directly apply this formula, square root of x square plus y square. Okay, you can omit or skip this first step. So directly square root of 4 square plus minus 3 square. So 4 square is 16, minus 3 square is 9, square root is 25, and it's a perfect square. So answer is plus 5 units. Negative value you omit. So in this way, very easily you can calculate distance of any point from the origin by using this given formula. Now some more application of distance formula. Determine if the points 1, 5, 2, 3 and minus 2, minus 11 are collinear. Now first of all you tell me what is the meaning of collinear points. Yes, so two or more points are said to be collinear if they lie on the same line. Right? So first of all, let us give some name to these 3 points. Suppose A has coordinate 1, 5, B 2, 3 and C say minus 2, minus 11. So to prove collinearity, what we'll do? First of all, we'll find distance AB, then distance BC and thirdly distance AC. And we'll check whether the sum of distances of any two small lengths is equal to the longer one. If you are getting this, that means the points are collinear, otherwise not. So let us do that. So first of all, distance AB, apply distance formula, calculate the value, you will get root 5. AB distance is root 5. Then next is BC. Again, x2 minus x1 the whole square plus y2 minus y1 the whole square. Coordinates you have, accordingly you substitute, simplify. So BC length is square root of 212. Similarly AC length you calculate, you will get it is square root of 265. Now let us add one by one and we'll see whether the sum of any two lengths is equal to the third length or not. So let us do that. So we observe AB plus BC is not equal to AC. If we add AC plus BC, that is also not equal to AB. Then thirdly, AB plus AC, it is not equal to BC. That means we are not getting the sum of any two shorter length is equal to the longer one. So what does it mean? That means the points are not collinear. Right? Okay. So now I have some MCQ type questions. Okay, 1 mark questions. Let us quickly discuss them and then I will just give you the hint. You solve yourself. Question number 1. The distance of the point P 2, 3 from the x-axis. So as you know, distance of any point from x-axis is its y coordinate. And what is the y coordinate of this point P? Y coordinate is 3. So the distance of this point from x-axis is 3. Right? Question number 2. The distance between the points A 0, 6 and B 0, -2 is. So here you need to apply distance formula. So you apply, calculate and pick the correct option. Now question number 3. The distance of the point P -6, 8 from the origin. So again we have seen formula for distance of any point from origin is nothing but square root of x square plus y square. So you apply that formula and pick the correct answer. Now question number 4. Point on x-axis has coordinates. So all the points which are on x-axis, they have their y coordinate 0. So here which is the correct option then? Option A. That will be of the form A, 0. Now the last question number 5. The distance of the point -3, 4 from y-axis. So distance of any point from y-axis is its x coordinate. But here x coordinate is -3. And you know distance is never negative. So what is the correct option? Correct option is +3. That means option C. You just remove that minus sign and positive quantity only you write. So that's all for today's class. We'll see some more examples based on distance formula. We'll also discuss section formula in the next class. Till then, goodbye. Have a great day. Thank you.